Hi everyone, I'm Angie Jones and I'm a consultant automation engineer. I specialize in advising agile teams on automation strategies as well as architecting automation frameworks. I blog on automation techniques at angiejones.tech, so you can check that out and subscribe there. And you can also find me on Twitter at techgirl1908. So I get a lot of questions from automation engineers who are very comfortable with scripting automation tests. However, they want to take it to the next level and learn how to build automation frameworks from scratch. So that's what we'll be focused on today. Building automation frameworks that are maintainable, extendable, and agile friendly. Let's begin. For today's demonstration, we'll build a framework to automate scenarios for a demo e-commerce site. Tools QA has one that I really like, so we'll use this one. The URL is store.demoqa.com. So here are the tools that I use for this demonstration. Eclipse for the IDE, Java version 8, Chrome for the web browser, and then Chrome driver is what I use within Selenium. So if you can use any of these or your own IDEs or Java versions or drivers that you'd like to. So moving along, assuming that you have these things installed, let's go ahead and open our Eclipse IDE. So here's Eclipse, and we're going to make a new project. So this project is actually going to be a Maven project. So if you go under Maven and select Maven project, you want to select this create a simple project and the default workspace location, and we'll give it a group ID. So we'll say this is the store demo and the artifact ID will be automation framework. All right, and then just click finish. So we have our brand new project here, and under here you'll see a lot of different folders. Let's start with the Pom. So this Pom.xml file is where we actually define what dependencies we need. We identify those. So I double clicked on that, and if you just click on this Pom.xml, and then we can type in everything we need. So here in my outline, I can show you what I have. I have a dependency for JUnit, for Cucumber Java 8, for Cucumber JUnit, for Pico container. So this allows a dependency injection. And I have some Selenium ones as well. So for Chrome driver, and then the Selenium support one has things for conditional weights and stuff. Okay. So this pretty much defines everything that we'll need as far as a dependency. If you click on, after saving that, click on Maven dependencies, you see that all of these jars have been downloaded, even some that we didn't explicitly identify in our Pom file, but those come based on these other ones we have. So this should be enough to get us going. You also want to make sure that your framework is using the right JDK. So right click on this and on the project and go to properties. Then we're going to go to Java build path and libraries, and see this is using Java 1.5, but I want to use Java 8. So I'm going to say add library and the JRE system library. Now if you install the JRE 1.8, then you should see that one. So I'll say give me the workplace one. If it's not there, you can also do alternate JRE and look for other ones that you've installed. But basically you want this to be the 1.8 version. So I'll say finish there, and I'm just going to remove this one because I don't need that one. And I'll go ahead and accept those. This view that we're in, I don't necessarily want to be in, so I'm going to switch that as well. So I'm going to say perspective, and I would like to be in the Java perspective. So done with the Pom file, done with the Java. Now we can start looking at building out our framework. So if you look here, we have a couple of folders here. These first two are our main concerns. The first one being source main.java and this source test.java. These two are the ones we care about. And I'm just going to delete these resource folders. Okay, so we have our main and we have our test. So the main section, this is where your framework is going to be defined. And the test section is where your test is going to be defined. So you want to split these up and have a distinction between these two layers. By doing so, you're making your framework layer more reusable across the test. So everything isn't embedded within the test itself. Okay, so we're going to do a object-oriented approach to this. Okay, so starting off on the test layer. Okay, so the first thing I want to do is go ahead and add the Chrome driver. So that's one more step we need to do. Wherever you downloaded that from, just get the path to that or move it to somewhere secure. So I like to put mine in the workspace itself. So I'm going to do a new folder called resources. And I'm going to add my Chrome driver.executable file there. So I'm going to add it there. And I already have it in my buffer, so I can just paste it. So notice my Chrome driver there. Okay. Now, the first thing I want to do in the base class. So again, we're going to do an object-oriented approach here. So I'm going to make a generic base test class. And in that generic base test class is where I'll have things that are common among the tests. This is where I will instantiate the WebDriver. This is where we'll do things like launch the browser and close the browser. Things that need to be done with all of these different tests. But shouldn't be done within each and every test itself because you're just repeating code. Okay, so what I want to do is make a new sub package under this test one, and we'll call this utils. The reason I'm making it utils is because this class won't actually be a test class, but it's just served as a base. Okay. So in this class, I want to make a WebDriver variable. We'll make this WebDriver. And I'm going to add a method to set the Chrome driver property. And I need to give it the system key. So that would be webdriver.chrome.driver. That's always the same for the Chrome driver. And then the second one is the location where you have that Chrome driver executable stored. So again, mine is right here in my project under resources, Chrome driver.exe. What I also want to do in here is make a method that will launch the browser. And before doing that, I'll just call this Chrome driver property. And then I just need to instantiate that WebDriver. Okay. And then the command to actually launch the browser is webdriver.get. And you will pass it in the URL. So I'll get that URL. It was store.demoqa.com. Okay. And let me put my HTTP and all of that jazz. Right? Okay. Cool. And we'll import everything we need. So far so good. That will actually launch the browser. Okay. A couple more things I want to put in. Let's add something to close the browser. And that's just a quick command. Remember, we're inheriting from all of our other tests, we're going to inherit from this base test class. So JUnit has these annotations called before class, after class. They have other ones as well. But I'm going to use those annotations on this launch application. So before class, and I will put an after class on this one. So what this is saying is before you run every test class to go ahead and launch the browser. And then after every test class, go ahead and close the browser. So by adding these annotations in this base class, this stuff will be done automatically. So every test doesn't have to launch the browser and close the browser. Okay. Right. So I'm going to add a little more functionality here. What I like to do is with anything that I'm calling that's making some move on the application, on the browser, and it's changing the page in some way, I like to give a handle back from that method to the test class so that the test class has a handle to the page itself and can do some things. So what I want to do is go to the framework piece. And in this framework piece, we're actually going to make a new package called pages. So we're going to implement the page object model. And what that is simply having a page, a Java class that represents every page in your application. Right? So in the Java class, you would have the elements that you need for the actual browser page, and then also any methods that you would need to manipulate anything on that page. So this is extracted out from the test layer so that you can reuse them, right? So more than one test may need to do things on a specific page. So you don't want to build logic in the test that actually manipulates the page itself. Okay, so in this pages, I'm going to make a new class, and this one is simply going to be called page. Much like the base test, this page is going to serve as a base class. Okay, and we'll come back to that. But what I really want to do, add a handle to the page so that our test can access that. So I'm going to make this a protected variable called page. And the reason I'm making it protected is so that my test class will have access to it. Okay. And then in here, after I launch that, I'll just go ahead and instantiate that home page object with a new instance of the page class. Okay. And so that will allow us to use that home page in our test. Right. And then one more thing in this one, I'm going to add a method to be able to get a handle to the web driver, and you'll see why later on when we deal with more of the framework part. So in looking at our outline, we have two variables. Let's see. We have our web driver and we have our page. We have a before class, which actually launches the browser, and we have an after class, which closes the browser. We have a method to be able to get the web driver, which you'll need to be able to access any of the elements on the page. And then we just had a private method that was called from launch to set the property of this Chrome driver. Okay. So far, so good. One more thing that's kind of bugging me is this. This can be stored in a properties file or something like that. I'm going to make a new class. So we'll just make another package over here called utils. All right. And then in utils, I'll make a class called links. And so if you have like a lot of different links that you need to get to, you can do it this way. So this helps me keep things neat and tidy, especially if something might change with the links. So I'm just going to add a static variable, and this will be the store.demoqa.com. And then back in my base test, I'll just replace this with that. Okay. That way if it changes and if I need to access it another place in the application, I don't have to keep on hard coding that value all the time. All right. So there we have our test class, and I'll show you more about how to build the page class out for our framework. We're going to use the page object model to create Java classes that represent the pages within the application that we need to interact with. So first, let's revisit our class that we made called page. Again, this is a base class that other pages will inherit from. So this class will hold things that are common for any page in the application. Also, in this class, let's get a handle to the WebDriver object and store it here. That way, all page classes can inherit from this one, and there doesn't need to be a constructor that requires the WebDriver to be passed in for every single class. So let's go to the website and see what's common among the pages. With clicking around, I can see that this navigation bar is there all the time. The search feature is there, the checkout, and the My Accounts. So I can add these things to that page class that every class will inherit from. That way I don't have to duplicate that everywhere. So let's do that now. Now, with every action that moves the user to another page, I return an object that represents that page. For example, with this click cart, if I'm going to click on the cart, then I'm going to take the user to the cart page. And likewise, if I click on my account, I'm going to take the user to the account page. So I'm going to make new classes for these, and each of these will need to inherit from the page class by using the extends word. So from any of the page object classes, we'll be able to navigate the menu, get to the card, and view the profile. Most importantly is that we'll have access to the instance of WebDriver. So let's do that now. Okay, so we have our two pages made, and we'll go back to those and fill those out a little later. For this page class, we're going to add navigation method. So for the navigation methods, they're pretty generic. They will navigate to any menu or submenu item that the test chooses. So since we're not sure what page the user will navigate to, we'll return the base page back. And that way the test can safely cast to the specific page type that they need. So as you can see, both of these methods are returning the generic page class back. Okay. And then also one thing I wanted to point out with this find menu item method. So I refuse to let any of my tests deal with the WebDriver object directly or with any web elements or basically anything to do with the DOM at all. All of that logic is restricted to my page object classes. So while I made the find menu item method here, since it returns a web element, I've made it private so that none of the tests can access it, and it only is accessible here in this file. Okay, now let's add the search method. So this one's going to be pretty interesting. If we look at a search, let's just search maybe iPhone. If we look at the search, what we have here is a section where the search results are. So this is not exactly a page, but it is something that would benefit us greatly if it's in an object form. So for things like this, components within pages, I make widgets or fragments. So let's make a new package in our project called widgets, and let's add a class for the search results. Now the search results doesn't necessarily inherit from a page because it doesn't have everything that a page does. It's just a fragment. So I'm going to make the constructor that actually takes the WebDriver. And then in our page class, we'll add the search method there. So this will return search results. Notice that we're going to return the search results and we pass in the WebDriver to that constructor. So if a test calls into the search method, then they'll automatically get a handle to the search results, and they don't need to worry with the WebDriver themselves. So I think that's about it for our page class. Looking at this, we have methods that'll be able to handle all of the common things between pages. Now that we have a base framework structure here, I'm only going to add methods to the page object classes as we need them for tests. So this keeps your work to a minimum. And as we're trying to keep our automation suite as maintainable as possible, we definitely don't need to add dead code that's not exercised. So I like to think of this as TDD, or test-driven development, for automation as opposed to for production code. So let's look at our very first acceptance test. So this is searching for products, and it says, as a user, I want to search the catalog so that I can find specific products. And here's the scenario with the steps. So what I'm going to do is create a new package under our test area. So under here, we'll make a new package for search. So these are all, everything that'll go in here will be tests that deal with searching. And we'll make a new class called search tests. And this guy should extend the base tests. So remember, we get all those free goodies inherited if we do that. Okay. So inside here, let's just go ahead and write our test. And I'm going to write out the steps that I would need in order to complete this test. And for all the code that's missing in the framework, we'll add that to the framework to get the test to pass. So what we're doing here is we can go ahead and say which product we're going to search for. This home page, this is something that we inherited from the base test, remember? So in base test, when we do this before class, we launched the application and then we instantiated this home page object. So we can use this right off the break. And we're going to search for the product name, which will give us our search results back. Now remember this, we made this widget. We didn't add any methods to it. And so these are the type of methods that we'd be looking to add to that. So let's just go ahead and add each of these. So we've added enough framework to get the test to run. So let's go ahead and run this test and see if we can get it to pass. Perfect. So we see that it passed. So we've made enough framework for this test. So let's look at one more feature. So this is a manage cart one, and it says, as a user, I want to manage my cart so that I'm buying the right things. And in this scenario, we're increasing the quantity of something inside of the cart. Okay. So let's code this up. Now, that one was a cart test, so I'm not going to add it to the same file. What I want to do now is make another subpackage under this test one. So we like to keep things really neat. Okay, so we'll call this cart. And under here, we'll add cart test. Now, in this test, if we think about it, we needed to increase something. Matter of fact, let's look at the thing again. So it says, given the Apple TV is in the cart, when I update its quantity to 3, then its price should be $80 and its total should be $240. Okay, so if I think about this from an execution standpoint, the very first thing I need to do is find the Apple TV. So I would search for the Apple TV and then add it to the cart and then check the cart. Now, here's my issue with that. So the cart, this test is for me to make sure that I can increase the quantity in the cart. If I add the piece in here about searching for the product and then adding the product to the cart and things like that, then I'm adding too much to this test. It becomes more brittle in that case. For example, if something happens with all of those steps before, like in the searching and adding to the cart, then this test is going to fail even before I get to the piece about increasing the quantity, which is the purpose of this test. Also, let's say that the search feature is broken or it's down. So by me searching and adding to the cart, if I put that in the test, and then this test will be blocked if we have a bug with searching. And that's not what we want. Okay. So I think you all are familiar with the automation pyramid. And in the automation pyramid, we know that we need to have mostly unit tests, and then the next biggest number should be on service layer tests, and then UI tests. So a lot of people, when they're testing the UI, they think to themselves, okay, I have to verify this in the UI. For example, this cart feature, I need to make sure that on the UI, I can increase the number of items in this cart. But what I don't have to do on the UI is this whole given part. That's the piece that can be taken away from the UI and done at the service layer instead. So if I do this at the service layer, then this will speed up my test. It will make it less brittle. So this is all important in Agile as we're moving towards continuous integration and want to make sure our tests are as fast as possible and also are as stable and reliable as possible. Okay, and then also it should be quicker for you as an automation engineer. Once you have a good bit of these services built up, then you should be able to write your tests a lot quicker too. So let's go back to our framework. And so we're in the cart test, right? So let's go ahead and make the test. And then we'll add the framework for it. So TDD. Now, the reason I'm making a separate method for this set quantity instead of just doing it in the update quantity. So I might want to have another test later on that simply sets the quantity but doesn't click the button. Maybe it does something else. So as many actions as I can separate, I try to do so. Okay, so we have just about what we need. There's one more thing, this cart services. So I made a service class and I'll need to add that to our framework. So I'm actually going to add that to the framework piece. And we'll make another section called services, another package. And inside of here, so again, being as tidy as possible, I like to break the services up. So I would just say cart services. And any services that I had available for the cart, I would put in here. Okay. Now I know that there is a service available that will allow me to add something to the cart. So I'm going to use that here. And then this product, I'm going to make a new class called products as well. So this is not a page, but this will represent like a database type of thing. So I actually don't have access to the database to that application that we're testing. But if I did, this is what I would do. I would make another class for my database stuff, and I would make a call to the database to get the product ID, because the product ID is actually needed here in this web service call. Okay, so I'm just going to mock this out a little bit. And see that home came in handy again. So good thing we moved it to this link so we didn't need to hard code it. But yeah, I'm going to go ahead and mock the products out. And I'm going to put this in utils as well. So again, this would have been a database, but I have to fake it out for the sake of the demo. So I just added the Apple TV product to this enum with its ID. Again, this would have been stored in the database, but I'm faking this out for the sake of this demo. Okay. All right. Okay, so I think we have enough here to get this to run. Everything is compiling. Let's go ahead and test it out. Notice the card at 0 when we launch. We did the web service call. Now it's at 1. Go to the cart and then do the UI testing there, and it passed. So that is an example of mixing your service and your UI testing together, which is an agile friendly way to speed up your tests and also make them more reliable. Now we have a really nice framework that we can easily extend upon. So essentially, you've gotten the heart of the message here today. However, I do get a lot of inquiries about BDD and how one might use this in starting a new automation framework, or even how to go about adding one to an existing framework. So let's go over this a bit. So Cucumber is a tool that I use for BDD automation, and BDD is behavior-driven development. And we already have it included in our Pom file, so we can jump right in. The features that we've seen so far are already written in Gherkin, which is the domain-specific language that Cucumber understands. So it would be relatively simple to hook them into our framework. First thing we need are feature files that list the scenarios. So I'm going to add a package in our testing layer, and let's call this cucumber.features. In here, we'll make two feature files, one for the search scenarios and another for the cart scenarios. So I do have some additional scenarios, not the ones we've already done, although we could throw those in too, but I'll show you some other scenarios that I had as well. And these are going to be files. Instead of Java classes, you'll just do a file and name it whatever .feature is the extension. So I add some new ones to the search, and I'll go ahead and add that same one to the cart. So notice all of this yellow, and this is basically saying that there's no code behind this. So far we have the features, but we have to also add the glue, which is the code that goes behind that. Okay, so we'll make another sub package, and we'll call that one cucumber.step-defs. So step definitions are what we call the code that hooks into these feature files. Okay, and this will be done similarly to what we've done so far as hierarchy. So let's make a base step-defs class, and this will hold data that is global to all scenarios. So I have some variables here that I will add to this. And that way we can use this across the search feature file or the cart feature file or whatever else feature file we add. So this will be like our parent. And then let's make step definitions for the search and for the cart. Now, some people throw all of this stuff in together, but you know me by now, I like to keep things very tidy. This really helps with maintenance. Now, in case you notice, we didn't extend like we did with our UI test, where we had a base test and then all of the other test class extended from that. It doesn't quite work like that in Cucumber. So Cucumber has its own engine, and so we need to do something a little bit different with this, which is dependency injection. So in our subclasses, the search and the cart one, we'll add a dependency injection, and I'll explain what that means. So the dependency injection is done simply by having the Pico container dependency in our Pom file, which we do have, and by adding a constructor to the class that takes the base class. So this tells Cucumber to use the base step-def class that is already instantiated as opposed to creating a new instance of it. And this will allow you to share state between your step definition files. So I'm going to quickly add the code that's needed to get these feature files hooked up. So there's a little bit of framework that's still needed for these to get these to work. But notice, given what we've already written, we already have hooks for a lot of this stuff. So there's just a little more framework that's needed here, and we can reuse what we've already have from the page object model. Okay. Also, if there are any step definitions that are applicable to more than one case, you can put those in your base. So I'm going to add one to the base as well. All right, so I'm going to go ahead and add the additional framework pieces that we need. So this add product cart is different from the service one that we use. So remember we had one that's in the services. So this one is a UI one. So if we do have a test, which we do in our feature file, a test to actually add it to the cart, and that's what we're testing. So we can do that on the UI. Okay, so we've done our TDD and we got it all of the framework pieces that we need. There's one more thing. We need to add a class to run the Cucumber files. So they run a little bit differently. Let's add another class here called Cucumber Test Options. We'll add that right under the Cucumber package. So in this class, we specify that it is run by Cucumber. And we also specify where the step definitions are and where the feature files are. So this is enough to run all of our Cucumber files. There's one little quirk though. If you remember in our Pom file, Cucumber came with its own little JUnit. So that doesn't acknowledge the before class and after class methods that are written in our base test class. It has to be one that's in a Cucumber, run with Cucumber. So we need to add those calls here in this class as well. And we just point to those base test methods that were available to us. So that's all we need to add the BDD layer to our automation framework. So let's just make sure that our tests work. So let's change this a bit and make sure we have the right package there. Okay, so that should do it. And now let's go ahead and try to run this. So by running this will run all of the feature files. Okay, perfect. So our Cucumber test ran, and also under this test, so we have some Cucumber, which are all identified by the Cucumber piece, and then we have our regular test as well, our UI test. So we can really run all of these together. If we just go to the test layer and say run as JUnit, it'll run the entire suite, Cucumber and non-Cucumber tests all together. So there you have it. We've built our automation framework from scratch. It has layers for UI, for services, and optionally for BDD components as well. If you have any further questions after the Q&A session, you can catch me on my blog at angiejones.tech and send me the question, or you can find me on Twitter at techgirl1908. I hope you enjoyed. Thanks so much for tuning in. Bye-bye.